Hey buddy, welcome to another Changelog, where we will keep up to date with our preferred data and AI tools. Today, Lance v2, a new storage format for Lance with its creator, Weston Pace. We are talking new encodings and new possibilities, faster search for your specific data and use case, more customizability for the developer, and more diverse data representation.
I think one of the things that I'm excited about is we're becoming a little bit more feature complete with returns of Arrow. In that before with V1, we couldn't store nulls, for example. So you couldn't entirely round trip your data through Lance. And that's one of the goals, is to make sure that we can fully round trip in anything that comes through can go through Lance. And then the encoding question is a little bit interesting because Arrow doesn't have, for example, like bit packing or a lot of the encodings that are designed to reduce I/O size. So we'll be creating some different memory layouts that made things a little bit. I'm used to just using Arrow internally everywhere from like the very beginning to the end. And so there's a few parts when we get into allowing different encodings to take place where, from an Arrow perspective, it's just a var binary buffer, which is necessary because we want to be able to get that compression. But I've found anytime you leave Arrow and you just start dealing with raw bytes of data, then you lose all those cool utilities and helper functions and things like that exist. But for the most part, I think the relationship is just kind of helping strengthen that bridge.
Yeah, and the name, like columnar container format, can you break that down? Like, what do you mean by that?
Yeah, as I wanted to tackle that name because I realized as I was sort of finishing up the design that you can store a lot more than just tables of data. So one of the things I want to use it for, fun experiment that I'm hoping to be able to run pretty soon here as I work out the last of these bugs, is being able to use this not just for long-term table storage for searching, but also as a way to use it as a spill file for things like sorting a large out-of-core sort. So you have 20 gigabytes of data you need to sort. You can't put the whole thing in memory, sort it. So what you do is you accumulate, a few gigabytes, sort that in place and write it to disk. And then if you accumulate a few gigabytes, sort that in place and write it to disk. We can use LanceFile for that if we basically make each column one of the partitions that we're writing. And so each column has kind of the exact same schema, which is all of the data. But then, as a batch of data comes in, we partition it into maybe 10,000 different groups, and then we write each group out to a different column, and things just sort of work. But it's very not what you would expect from a table format. It's every single column has a different length. Every single column is in itself almost a table. So it's very weird use case. And so I thought, well, this is not exactly a table like a normal columnar file format. And then at the other hand, we want to enable all of these encodings so people can just kind of plug and play with different encodings. And that, I started to realize is very similar to some of these. I think as talking with someone, and they mentioned, it's like a container format. And so I thought, well, so I went and I looked that up, and for video files, you have your container formats, and it's like, that's exactly what I'm trying to describe, which is this isn't the encoding itself. It doesn't tell you how the data is encoded, but it tells you where to place the data and where you put your description of the encoding, and then you let people develop the codecs as they want to. And so I think that's where we need to get to with these columnar formats.
Yeah, and especially giving way more flexibility to the developer once it's finished. What do you think is the real new use case? It really enables, but also like what use cases become way more feasible now or way more performant?
Yeah. I think there's sort of three use cases that were driving our development initially. One is we needed to be able to store nulls and retrieve nulls, which is something that we couldn't do before with the Lance v1. That's not too novel of a use cases. There's many other file formats that do support that. But the other one, which is a little bit unique, is we wanted to be able to write large amounts of multimodal data. So images and videos jump to mind, but I'm even including like embedding columns where you've got each cell is basically, like a 4 kilobyte vector embedding. So be able to write multimodal data, a large amount of it, without requiring a ton of memory, and then without hurting the eventual read performance that you're going to get. And so that's something that we struggled a lot with, both Lance v1 and Parquet. Neither of them can tackle that problem too well, because normally you need to buffer an entire row group's worth of data in memory before you can write it out. So you have to if you have multimodal data, you need small row groups. But if you have small row groups, then it kills performance. So one of the main things I'm trying to solve is be able to both have multimodal data and good performance. And then the third use case is really, I guess, more, basically being able to have support for compression, being able to have support for sort of the right, I don't know if it's the right, but it's a good balance between point lookups and full scan performance. So row-based formats will have great point lookup performance, but they don't do so well on full scan. Parquet has great full scan performance, has not terrible point lookup performance. I've got a friend who's trying to use Parquet for point lookups, and playing a lot of tricks, they can actually get pretty good point lookup performance. But we want to be able to do a little better than that even.
Yeah. And especially looking into the second part, how are you actually enabling that? Do you actually just write like partial pages to the disk, or how have you implemented it on like a little bit of an abstract level?
Yeah. We don't even have to write partial pages. It turned out to be one, I don't even know if it's exactly a requirement in Parquet as much as it is something that every reader and writer has done, which is for a column, we don't expect that all of that column's pages on disk are contiguous. So with Parquet, within a row group, if you have some column, maybe it will get broken into 2 or 3 data pages. Those all need to be next to each other on disk. So you have page 1, then page 2, then page 3. So the main difference that we've made is it would encode almost in exactly the same way, but we don't need those 3 pages to be next to each other. So what that means is the writer basically has a queue for every column. And as data comes in, it checks every column. And if that column has got too much data in the queue, it's accumulated enough that we have enough data to write a big page that's going to work well with cloud storage, then we'll just write that page. And that's it. So then you just feed all your data in. Every single column will write pages as it needs to. So if you have a vector embedding, it's going to be writing pages, constantly. Pretty much every single time you go to a batch of data, it doesn't take many rows in a vector column to justify a page. But if you have a Boolean column, you're probably only writing 1 page at the end of the day. Because if you want like an 8 megabyte page, which is kind of a good target for S3, then you're talking about 64 million rows before you need to write a Boolean page. And that's assuming that you have no compression at all.
And what is something you would actually love to see built on top of the new file format? Like a really challenging use case you would love to see tackled?
Yeah. So I think I'm excited to see where encodings go. Later, probably this month or May, I want to make a cool little demo of being able to just use Python to create an encoding real quick. Not that it would give you great performance, but I think it kind of opens up the door for people to play around with encodings. So today, there are some great, cool papers like Better Blocks, Fast Lanes. I think Google released a paper about Procella and Artis. And each of these are talking about, oh, we tried these different encodings and we got this great performance. But they basically had to write an entire file format themselves. Or they wrote these encodings, but they didn't actually, really test them in a full file format. They just sort of unit tested them, so to speak, and are able to benchmark that. And that's a lot of work. So I think it'll be cool to see, if we have this extensible encodings mechanism working pretty well, people can play around and they can say, oh, I tried out this encoding and then I just wrote a plugin for Lance real quick and got this performance on this kind of input file. So, just one, there's already a lot of, I think, basic encodings that we could use support for. So it'd be cool to see as those grow. But two, interesting to see what exotic encodings people come up with specific to their situation. So, like one example that I don't know that I'll be writing anytime soon, but it would be cool to see is if you were storing an image data set and those images were heavily normalized, so something like a face recognition data set, you can get probably really good frame of reference performance where you have your average face image as a baseline. And then as each image comes in, you're just subtracting from the average image and then compressing that delta, which is going to have a lot less information in it. So you should be able to store that image data set in a much smaller total file size. You would get much better compression than you would just throwing something like gzip on top of it by using this frame of reference. So it's almost making like every record batch at that point is becoming like a tiny MPEG movie that gets stored on disk to hold all of your images. So those are the sort of things I think would be cool to enable by allowing encodings to be flexible.
Yeah. And if someone wants to write their own encoding, you already mentioned they can do it in Python. What would be like the most performant way to do it? Will it be purely Rust? Or what's your plan for that?
Yeah. So if you were, it's a fair question. Rust is going to be probably easier to get great performance. At the end of the day, if you're kind of depends on a lot of factors, but you're probably not creating pages all that often compared to your ingress speed. So using Python wouldn't actually be the worst thing in the world for like a trade-off. One of the cool things with Arrow is you get nice zero copy between different languages. So something like, an encoding interface is basically array in and then just, an array of bytes out. So we can hand over that array to Python really quickly without doing a full copy of the array. We just copy the pointers. And then if you were to actually implement that encoding in Python, you'd probably get bad performance. But you could implement it in whatever native, C++, Rust, whatever kind of language you're working with. And Python can do the handoff. So for experimentation, you can sort of use Python to plug your encoding into Lance and test with it, even if you're writing in C++ or Rust. But at the end of the day, you're probably wanting one of those languages, maybe Go, one of the system languages to actually implement the encoding itself. There are probably some cases where you could use pure Python if you're using pandas or polars or one of these libraries that's delegating the actual work to Rust or C. That could be useful as well. To get nice thing about encodings is that they're just like they're just a CPU process. So it's something that I think you get a lot of nice tools for how to optimize and fine tune the performance. They're sort of fun. You can play around with some D. You can, fire up your profiler. You can, it's your writing something that's purely CPU and optimizing that performance is well understood. It's when you have like a blend of CPU and IO and writing a query engine or a database or something like that. You have to think about performance in a much different way. But I think for encodings, it doesn't require a ton of foreknowledge to do correctly.
Yeah, and I'm really curious, what did you change to the file format, or what did you add to actually enable the non-contiguous columns and still enable column scans and filtering?
Yeah. So the key here is we just needed to have a page lookup table in the metadata in the file footer. And this is something that Parquet didn't start with, but it evolved to have anyway. So in a way, it wasn't even adding something all that new. But with a normal kind of classic Parquet style, the way you would scan a column, it's first you read the file footer to get the basic information about it. And then you pick the column you're going to scan, and you read the metadata for each row group for the columns that you want. So you would sort of start with the footer read at the end, and then you would go through, and at the beginning of each row group, there's a metadata chunk. You would read that, and then you would read the data. That was already troublesome for any kind of, even if you're doing like statistics-based filtering, that becomes a problem, because if you're only reading a few pages from disk, you still have to read the metadata for every single row group that you watched. So the way that a page lookup table works is it takes all of that metadata, or at least the important bits, and puts it all in the footer. So first you read the footer, which is now larger, but it has all the information you need about where the relevant bits are on the disk. And then you just go off and read the pages that you need. So I think this is probably something that Parquet would have supported originally had they started with a point lookup table in V1 or so. But because they kind of evolved there, they still have this requirement for contiguous pages within a column. So it's just sort of, again, the next step of natural evolution, which is now that we have this point lookup table, we can get rid of all of this metadata within the row groups themselves.
In LanceV2, I think the most important thing for me is, on the one hand, the metadata. So the metadata really is the star of the show. Most table formats already have put metadata at the center of attention to enable asset transactions, but also rollbacks to previous states, but also the schemas. LanceV2 amplifies it even more by choosing what data to keep in your metadata and also what statistics to keep in your metadata, like the min max of the different columns, or even a mean, the unique values. You can have much more customizability, and you can decide to lay out your data and your statistics in a way that optimizes for the way you actually query it. So you actually get much more flexibility. For the encoding, what I'm looking for most actually is new innovation. I think in the encoding space, there is a lack of open innovation where people can just try out stuff and figure out something new, because most people aren't actually working on on our databases and how the data is represented, but they're using the existing tools. And I think Lance v2 gives you a little bit more power to actually just try out some stuff which is really optimized for your specific data, which can lead to weird data representations, but weird data representations that are actually really optimized for your use case. What I'm looking for most, I think in general in Lance, what I'm looking for most is full text search capabilities in a bucket, so in cloud storage, because that's something that I'm missing the most from the current Lance. The potential downsides of the new versions, there's still lots to figure out. So it's getting started right now. I think there aren't so many encodings yet, like Weston mentioned. But we're getting there. And I think if a bunch of people contribute, it's getting there fast. But also it pushes more to the developer. So you actually have to be careful, like what to represent and how to encode your data. Or Lance has to be very careful what are the default encodings and the default metadata representations they choose. And I think this is something where they really have to spend some time. See you next week.